Okay, welcome. So this is Crux Showcase 12. Hope you're all keeping well. So we've got a few things to discuss today. I've got lots of people in the call, which is always a nice thing. So first up, we'll look at the console with Dan. I'll leave it to Dan to explain a little bit about what that is. But yeah, if anyone has any questions, just feel free to interrupt. Otherwise, we'll cover that at the end. But yeah, hope you enjoy today's content. So Dan, would you like to share your screen, or?
I'll start that in a minute, but thank you, Jeremy.
Okay.
So I just wanted to start off with a bit of background on the console, kind of the motivations for what we're doing now. So there is a pre-existing Crux console project currently hosted under Crux Labs, I believe, and it was made a little while ago. Has a number of desirable features to it, but we wanted to kind of go back to it and sort of rethink it a little bit. It had a monolithic design, which we had to maintain parts of separately. And it implemented things like its own async HTTP client for Crux. So it either started a Crux node or connected to one via like the remote API interface, meaning that you had to have a node with a HTTP server with cores set up properly. So there was kind of a separation between this Crux console app and Crux itself, which is kind of what led us into what we've been working on. So this new HTTP console lives alongside the HTTP server and offers a set of views over your data. We kind of wanted to bring it back to basic, taking a bit of more document-focused approach to it, kind of how we build it and how we expect someone to use it. So it's been a bit of work by myself and Lucio over the last couple of weeks. Still early days, but so far we started by adding some new endpoints to the HTTP server called _entity and _query. And it allows you to ask for your data with a number of different content types. So currently that is JSON, Eden, Transit, and what I'm going to be demoing, which is HTML. We've been building a single page application around it, which gets loaded when you request it. So yeah, currently we've been focusing on entities and queries, and I'm going to present my screen and kind of show you a little bit of what we've done. So hopefully... Is that good?
Yep. You see.
For demo purposes, we've got a couple of little pre-existing queries that we've got. Essentially, we made a little test data set as well, just to kind of show off the tables. So I'll start off with this one. It's a relatively big query, but I'm going to add a limit to it, so we're not displaying too much on the table at once. So you can select a valid time and transaction time to add to your query params. And yeah, it's essentially this is a table built using something Lucio built called Crux UI Kit, which is also up on Crux Labs at the minute. But yeah, so this is kind of like a table over a set of query results. It's paginated, so you can go through, and it goes through using offset and limits. And it's also kind of you can sort on any of the headers and search via any of the headers. So, for example, I can search based off of position, or in the top left, I can kind of search based on any general any kind of general attribute I want. So that's just kind of a simple table. And the other query that I have links in some entities. So it's a set of orders with order IDs, employee IDs. So having a look at those, we link to entities based off of their ID. So off of this table, I can kind of dive down and take a look at the underlying documents that this is built off of. So, for example, if I go have a look at order ID, I can have a look at this particular order document, which in turn links to some other documents. So I'll have a look at the employee related to it. And then again, I can kind of dive down and have a look at that employee's address document. And yeah, there's kind of bits that we want to do with this. Currently, you can just kind of navigate up and down using browser history, but that's kind of the state of it. So currently we've kind of got our query tables, and we've got some just a little bit of like document exploration going. So yeah, that's a relatively short demo of what we've actually got so far. But the idea is like we'll add more bits to it as we go, kind of bring it all into. We kind of want it to be like something someone can open up and take just a good look through their Crux node. I'm gonna end it there. So it's relatively short and sweet, but hopefully that was helpful, exciting.
Thanks, Dan. That's very, very good. So I think one thing that we've seen there, which the other console didn't quite address, was the ability to really navigate through these documents, the layers, and of course your back button in the browser history will respect the way you're navigating. So it's really tied up quite nicely. So that's very exciting. We have lots of ideas and plans about how to sort of extend this as well. So when you have like a URL ID, you could use the URL as an entity reference to link potentially different Crux databases together. So I think quite a few people in the team have seen things like CouchDB and how well they have an HTTP interface that's sort of baked into the database, and that really sort of a very promising vision that we don't think many databases really take that seriously. So we're also quite keen to explore that. Certainly Malcolm's the visionary there. If he has any words, he can certainly unmute himself and share. Otherwise, we'll move over to James to talk about the S3 support, and specifically the use of S3 for the document store. So instead of using Kafka for the transaction log and the documents, you just use Kafka for the transaction logs and S3 for a sort of cheaper option for storing the documents. So James, over to you.
Cheers. Thank you, Jeremy. I'm just going to share my screen as well, actually. If that's all right. Everyone see that okay?
Yep.
Excellent. All right. Yes. So Jeremy says yes. S3 support. So actually, we jumped really to the end of the story there, I guess. And S3 is kind of the benefit that we're going to be getting from all of this. But I just wanted to touch on a bit of the background behind what Crux does and why we've made these changes. So first of all, obviously Crux is unbundled. So we like to give users the choice of the underlying components that they want to bring into their infrastructure, and we really base this on top of things like Kafka and things like Facebook's RocksDB, software that's sort of that's had an awful lot of development time put into it. And so we're really benefiting from the sort of the scalability and the reliability and performance characteristics of all of those. So up until recently, as you've probably seen on the Crux infrastructure diagram, we've mainly really supported Kafka on this. And Kafka we've split up into two topics in Crux. We split it up into the transaction topic and into the document topic. And so this is an example transaction here. So let's say I'm putting a document in about Luke. We actually split this up into two. We split it up into the document itself. We then hash the document. So the document comes out with a hash of like E9. We put the document on the document topic and the transaction with a reference to the hash on the transaction topic. It's not a hassle. But the reason we do this is so that if, for example, Luke were to come back to us later, as is more than entitled to under sort of GDPR and I think the Californian, the new law in California as well, and says, I want you to remove all of my data. Right? I want you to irretrievably remove all of my data. We then only have to remove the data from the document store, and there's nothing personally identifiable in the transaction log. We've actually taken the step now within Crux to split these components out as well. So previously, the same component was responsible for both making sure that the transactions got through and making sure the documents got through. And that's fine in the case of Kafka, but there's a few others where it doesn't really make much sense to have a transaction log. And S3 is our first example where it doesn't really make sense to have, it doesn't really have the characteristics for us to use as a transaction log, but it does make a very good document store. So I've heard. So I've heard. So S3 support. Looking at what this then looks like, I'll jump into our user CLJ. Apologies, that's my dog. So she's barking up. Okay. There's always one, isn't there, on every video call? There's always one. All right. What was I? User CLJ. So this is within the Crux. This is within the Crux repo. And how I've got to this, just in case you're interested in playing along at home. I can actually say playing along at home now as well, given that we're all at home. Head into the Crux repo and just run line REPL in your normal way. Connect to it in your editor, and you can use this user namespace and try it out. So what we've got here is a basic standalone configuration. At the moment, it's set up with RocksDB, and we also use an HTTP server on a fairly regular basis. So I've got that in here as well. So to use S3 as a document store, we simply have to add S3 to our topology. So I'll add this in now, S3 doc store. I'll reload that. We're just looking to see integrant come back up again. There we go. Oh. This is why you don't ever do live demos. Because I've not put a bucket in. That would be why. There we go. So I need to put in a crux.s3 bucket. And the bucket I did make earlier, it's called a crux JMS test. Let's try that again. Crux S3 bucket. There we go, bingo. So we've now got ourselves a Crux node, which is hopefully putting our documents into S3. And I can have a look at and see whether this does it by writing out a quick transaction. So let's do crux tx put crux.dbid James. And I'll put name James in here as well. And when that transaction gets submitted, as we can now see that's been submitted, what I'm going to do is just head over to S3 very quickly. And let's see that document having been put into our S3 directory. There we go. So we key them by a hash of the document, as I said. And if I were to download this, at the moment it's using Nippy by default. So if I were to download that, and then have a look at it. Temp downloads. It'll be that one there. Oh, it's roughly recognizable. You can see some bits in there, but it's definitely Nippy. So that's a real basic demo as to how S3 works. Obviously, there's a whole load of S3 configuration, right? So whether it be where you get your credentials from, in this case, we use the default credential store. Whereabouts you store it within the bucket. So in this case, we're just using it from the root. And indeed, how you whether you want to encrypt the documents on S3, for example, and then again how you want to serialize and deserialize them. I'm just going to give a very quick demo on how we do that. So if I add in Crux S3 configurator, and I can add this in. I can add this into my map here. And this one I am actually going to check my little crypt sheet here. Because I don't think I was going to write that out right first time. So what we need to do, we need to implement one of these S3 configurators. And I've been a little bit sort of tongue-in-cheek about the name there. We may well change that one. But what I need to do is implement freeze and thaw. And in this case, freeze takes a document and needs to turn it into a byte array, and thaw takes a byte array and needs to turn it into a document. So if I evaluate, obviously I don't recommend doing this. I don't recommend changing the serialization on a real node. Halfway through, that won't go too well. But on a test node, it works quite fine. And I'm hoping now that once that refreshes, that's looking good. I've now put another transaction into it, which will hopefully override the document. And I'm hoping the size changes when I go to S3. 35 bytes. Excellent. I'll download that again. And we should now see, there we go, that's nice and plain Eden. So that's a brief introduction as to how we can then configure that S3 node. This obviously actually opens up quite a lot of possibilities, because this opens up the possibility for you to implement whatever document store you like. And if we have a look at the document store protocol, in fact, I'll just go to the S3 implementation. There's really not an awful lot to this. Document stores need to be able to submit documents and fetch documents. And this is pretty standard S3 implementation using the AWS SDK. So if you can implement submit docs and fetch docs, then yeah, you can create your own document stores, store them wherever you like. You may even have sort of document stores available already within your company. I'm sure you'll be able to implement these. Looking forward to see what people do with it. Thank you very much.
Awesome, thanks, James. I'll continue trying to present my screen. Hopefully, yeah. So I think they. I mean, it's something we've kind of had almost working for quite a while now, but it's great to see it materialized. Yeah, we potentially will get support for Azure in the near future as well, which will hopefully be almost identical in terms of complexity and whatnot. So anyway, so that's S3. The next thing to discuss would be the SQL and Metabase work that John and I have been doing. So in the previous showcase, we did discuss this, and we just discussed how we'd been running some TPCH tests as well. So so we've been using something called Apache Calcite, which is a it's like the front end of a SQL database without any storage capability or any any actual decisions about how your data is stored. So it's a Java Apache project, which is used by tons of other database technologies, some open source, some closed source, some venture-backed companies, etc. Anyway, it's very interesting technology, and we've been gluing it to Crux in order to provide a SQL option to users. So, you know, a lot of times when people hear about Crux, they're excited that there's something which can do this bitemporal thing, but then they see data log and then they're like, oh, okay, I have to learn something new, or you know, I don't think I'm going to be able to get this to fly past you know, the management team who aren't comfortable putting in a database which doesn't have a SQL interface, or maybe there's a business team which really need access to the SQL database, to the data store, but via a SQL layer. So that's where something like Metabase comes in, where you're able to as a non-technical user or someone that's only familiar with SQL, just dive around all the different data stores that are available in an organization. So so we've been working since the last showcase on a few different areas. One of them is pushing down joins into Crux. So before, Calcite would execute various data log queries under the hood, and then it would join the results together in memory. And now we have certainly inner joins being pushed down by sort of concatenating the where clauses in the data log, and then running as a single query in Crux. So actually the performance is basically the same, and you know, you're making use of the underlying Crux query engine without having to artificially sort of do things in memory when you don't have to. So that's really exciting. And another thing we've got working is prepared statements, and this is a key thing for getting Metabase support working. So so we've been thinking about Metabase for a while because it's quite a popular BI tool. I'll just show the site in case people aren't familiar. But the idea with Metabase is that, you know, it's a nice GUI front end for building these SQL queries and storing your sessions almost like a notebook across many different databases. And if you looked on the GitHub issues for Apache Calcite support, you'd have found actually it's not properly supported, or at least, you know, need prepared statements. And it just so happens that 24 days ago, someone managed to get a Dremio driver working and released it up on GitHub. And Dremio uses Calcite. So I took this driver, swapped out one of the connection parameters, and imported our new our own Calcite driver module and import statement, and it's worked. So I'll show you what that looks like. in this console here. So we have our Dremio driver, which we just renamed to Crux here. You can see there's not a lot of code. It's 246 lines here, which is quite small. A lot of it's commented out. There are various things which do need testing still. I need to run the full test suite, but it's a glimpse of what's possible now. We have SQL support. You can just plug in these relatively standard tools via slim adapters. If we were trying to do all this via Datalog, it would be a much more difficult integration. We don't really have to understand a lot more of the different features and how to support them. But Calcite provides a lot of things that even we don't have in Datalog today. So yeah, there's quite a few interesting benefits. So if we go to our Metabase, so I've actually compiled this driver and I've linked it into a Metabase instance I'm running locally. So this is the you can see the Metabase is running here. If I go to Metabase, you'll see, if we go to our home screen, so there's a few different data sets I'm experimenting with. Now these could be completely different databases. You could have your Oracle, your MySQL, your DB2, and then a Crux instance. And then if you want to add a new one, it's as simple as going to add into the admin thing. But before I do that, I just want to actually show you the Crux node running. So here I've got a REPL session open, and this is just a project I created for testing the SQL. The Crux SQL extension, which is still in a PR. It's a snapshot release. So I believe I don't have a node. Let's check it's. Oh no, I've just started a node, so I'm gonna just make sure I'll make sure it's empty. I'm closing it, restarting it. Check the status. That's fine. Number of keys 1. So what we can do is just make sure that we put something in there. So the way this integration works is that tables are defined by or backed by Datalog queries. So here we've got a couple of tables, person and planet. You'll see under the query we've got this find clause which maps to these columns. So these essentially become the columns in the SQL table. So ID, name, and planet are the columns in the person table. And ID, name, and climate are the columns in the planet table. And I can run a transaction to submit both of these as documents into Crux, and which we can then use as tables. And I'll also just submit this other table because it's kind of interesting. So basically, one of the things to get many of these tools working is you need a way to show all the tables. And one of the interesting things about defining your table schema as documents is that you can just write other tables which explore the documents. So anyway, so you can create an all tables table, which actually just looks for all the document tables and returns them. But a bit confusing. Anyway, I'll transact that in, and we'll just put in one document for the moment. So if I'll go back to this Metabase. I can click on admin. We'll add a new database. Now you can see we've got Crux in the list. So this wouldn't be part of the default Metabase installation unless we raise a pull request with the main project, which is an option. There's a bit of work to do that, but it'd be great collaboration. They're a massive closure company, very, very, very popular technology. So we'll call this one Crux 10. Why not? Give it a URL. And let's call it test schema. That's fine. Okay, so that's everything I need. Just before I do this, though, I'll just confirm that I can actually connect to it. So I'm going to go into a command line SQL tool, and I'll just run a query just to make sure I really am connected. So I can just do select star from all tables. Hold on. There you go. Okay, so this is live. It should run. So if I press save now, yep, your database has been added. I'll explore this data. So here we go. So Metabase has scanned the schema. It's already suggesting the different tables that are available. I can click on the person table, and it shows me this record of Ivan who lives on Earth. So that's interesting. So now I can go back to Emacs and add some more data. So I can say, well, we've got another one for Jeremy who lives on Earth and Yoda that lives on Neptune. Okay, so let's have a look what those look like. So if I refresh the page, there's a refresh button somewhere. I'm not that familiar with Metabase. There we go. So now we've got 3 documents, and it shows the planets and the distributions. So it's, one of the points of Metabase is you can very easily build nice graphs as well. And if we actually click on the table, so well, we look at this. Yeah, it pulls out more stats like this. But crucially, in the other table, in the planet table, although it's transacted, there isn't actually anything in there. So we can now go and submit some planets. So we can say, let's put Earth in there, which is hot, and let's put Neptune, which is cold. Now, because of the way Crux works, we're referencing the we're essentially referencing these other tables, but indirectly. We're not using a primary key. So where we've got planet Earth, that's a string. It's not the ID of the other document, but we could do that potentially. So in this instance, we should now have all of this in our database. We'll just confirm that. I'll just refresh the screen again. Okay, it says I've got 1 planet. Oh yeah, there's a typo. So I needed to change it to be a different ID. So it shouldn't be planet Earth anymore. It should be planet Neptune. Like that. So we can retransact. Because of the way Crux works, we've put a new document in. If we wanted to go back and see the previous state, we always can, because we've got the sort of transaction time, valid time magic going on in the background. Unfortunately, Metabase doesn't have valid time or transaction time support natively, but I'll get to how we might work around that in a moment. So here we go. Now we've got Neptune is cold. So that's done something.
Need to transact Earth again, Jerry.
Oh, I have to transact Earth again, you think? Well, oh yes, because it was still the old value of Earth. Yeah, thank you. Okay. There we go. Brilliant. Okay, so now we can do some interesting stuff. So we go back to browse data. Where is it? Crux 10. Right. So we got these 2 tables now. So again, we can just click on the tables, and it'll show us in a tabular view, or we can go to that sort of visualization. Got all kinds of things available. Don't know what a line chart would show, but what we can do with Metabase is ask a question, and we can do things like a custom question, and we can say we're going to use maybe a variety of data sources, just the one this time. And for the basis of our question, we'll look at the person table. And what we want to do is join from person to planet, where the planet the person is on is the same as the name of the planet in the planet table. Right, which is a very simple join expressed in SQL. If I press visualize, it's done it. So it's looked at those 2 tables, scanned for all the matches, and importantly, because it's gone through Calcite, you can actually see the generated query. Where can you see that? This one, here you go. So this shows the query that's generated, but this gets rewritten into Datalog, and it gets rewritten as one Datalog query. So it's very sort of an efficient process, and you can just run it again on the command line to see the same result. But yeah, what's nice about Metabase is you can just construct these queries, and they're very good for people that maybe don't have time to learn SQL, or don't have to remember about typing in that extra semicolon. So yeah, it's a very powerful tool, and that's pretty much that part of the demo. But yeah, obviously one of the great things about Crux is this whole valid time transaction time aspect, and because there is no way to express like an as of in Metabase currently, one thing we could do is add a connection parameter to the database. So when we added a database, you could add a database at a point in time, something like that. We might be able to get as a connection string option. We might be able to get something more advanced working. Outside of Metabase, we have been working on that. So we actually have the ability now to add, if you prefix your SQL query with this special valid time syntax, it will use these point-in-time coordinates. Currently for valid time, we're still working on transaction time, but it'll run that query at that point in time. Again, as a very sort of clean abstraction onto Crux, so it's just as efficient. And that's quite a novel thing for a SQL database to be able to do quite that efficiently. So we're really excited about that, and that'll be a fantastic milestone. So that's the overview of SQL and Calcite and Metabase. I don't know if anyone had any questions, or we can dive back to the next point in the agenda, which is James's event bus, which is something which has been driven by a few questions of the community recently, but also we've sort of we've been thinking about it for a while, but it's great to have enough momentum to be able to deliver on it. So over to you, James.
Thanks, Jeremy. Yeah, quite a lot quicker one this time. Let me just share my screen again. How's that?
That's it.
Excellent. All right. So we'll head back into user for this one. So again, a little bit of background for this. We've had quite a few people, as Jeremy says, asking us how they can react to transactions going through Crux. There's any number of use cases for this. Things like sort of notifications or various sort of real-time applications. You can really imagine the sort of scope of what this allows. We've had an internal bus for a little while now. The internal bus, I think we may have even presented it in a previous Crux showcase. If Tom would have done a demo on Crux metrics, and that's all based on the internal bus. But we figured it was about time to actually expose this to our users as well. So the way we do this, so now that I've got a Crux node up and running, I can type in Crux listen. If I give it a Crux node, there we go. I can give it various details about the event I want to listen to. At the moment, we've only got one, but we're looking to obviously expand this in the future. Index TX is the event I'm interested in. And I'm also going to supply it with TX ops as well. Once I've done that, I then pass it a function, and then I say what I want to do with this. So I can say event received. And I may well, I'll tell you what, let's have a look at it. Closure pprint. Let's have a look at what the event does. So that's me having listened on the Crux event bus. I should now be able to submit a transaction. Hey, there we go. And I get a lovely event received over here. So I get the event type, the transaction committed. So that shows that, for example, if I was to have a CAS or a match operation, the transactions can sometimes roll back if the precondition doesn't hold. But this one didn't, and so it committed fine. Some details about the transaction itself, so the time and its ID, and finally the transaction operations. So I guess with that one, we're really looking forward to seeing what people make of that one, and all the applications that may well now be possible.
Yep, that's awesome, cool. And hopefully there'll be
easy.
A whole bunch of people that can delete some repetitive polling code, which I'm sure exists. So yeah, and Jacob O'Brien's been working on something called BIF, which will definitely benefit. So thanks everyone for highlighting that. So yeah, the next thing just to mention was a few other changes that have happened, not really that necessarily affect the end user, but worth maybe understanding. Although you did just mention match, James, so this is actually something that came out in the 1.8.2 release. So if you haven't seen this, matches are decomposition of CAS into a match and a put. So rather than doing this CAS thing, which is arguably complected or doesn't need to be this sort of compound operation, we just pulled it out, and so matches are a replacement for that. CAS is still there for backwards compatibility for the time being, but that's one. So there's various things in the awaiting release column currently. So some interesting things on MySQL and MS SQL support. So anyone that's using the JDBC backend instead of Kafka. I'm imagining a lot of people use Postgres, but there definitely are people interested in the other databases too. So those are some good changes. But one that I think maybe is worth flagging is the use of spec to manage ingestion. So yeah, so this is part of our ingestion efficiency improvements. We took out spec because we weren't using it that heavily, but I do know some people were using spec to, well, they're relying on Crux's spec to validate the documents they're putting in, so they'll have to do that as a separate step now. So that's one aspect. And James, did you want to just say briefly what we're doing with the query engine component?
Yes. So this is more Hawkins territory really than mine. But what we're looking to do really is split out a number of internal concepts. So at the moment, the query engine is quite coupled with some of the other low-level areas of the system. So I'm particularly here looking at the underlying KV store. And so what we're really trying to do with both the query engine component and in fact that index store card a bit further down is just like loosen the coupling a little bit. And hopefully what that should allow us to do is to experiment with other changes a bit quicker. So for example, we're looking very much at the moment into ways to optimize the disk space usage of Crux. And hopefully these changes will allow us to make, these index store and query engine changes will then allow us to make much more isolated sort of spikes to see whether the performance and sort of disk space improvements of various different approaches that we've got in mind.
Yeah, and it should hopefully make it a lot more accessible for people just sort of reading the code for the first time instead of having the query namespace sort of reaching right down into codec. It's going to go through an abstraction now, which is the index store protocol, and yeah, opens up possibilities in the future. So that's good work. And I don't think there's anything else necessarily worth mentioning unless anyone spots anything. But I did just want to mention this change to the history API, which is going to come up. So right now we have quite a few different functions. I mean, there's 4 listed here. But then you've got the different lazy versions. So open history being different to just history. Anyway, so we've got quite a few different versions of history, and none of them do everything very comprehensively. So someone really has to study the documentation to understand which one to use and when. So we'd like to really simplify this, which is long overdue work, but again, a critical thing we want to hit and have done right before we finish the beta period. So what's on the right of the screen there, this entity history APIs are something which amalgamates the functionalities from the other 4 into something which is hopefully simpler and just sort of more intuitive. You don't have to read the docs to figure out exactly what it's going to do. So that's something we'd certainly welcome other people's feedback. If anyone's using the history API, that'd be very good to know. A lot of people won't really need to use the history API because of just being able to use the point in time queries. But for a lot of use cases, certainly anyone trying to do any time series work or something, they would hit this quite quickly. So hopefully that all makes sense. And as ever, like there's lots of things on GitHub. We're always welcome to have people leaving us comments. But equally, we are very keen to talk to people. So if you are looking at Crux or using Crux, just get in touch and we can have a half an hour on a video call. It's never a better time for video calls. So let's chat. And with that, I'll open up to Q&A. I know we've got a couple of people on the line. What do you think of everything?
Sounds pretty cool.
Yeah, nice
Cool.
guys.
I have a question about the S3 example you showed. So is Crux append only because did you override a record, a document there, or did I miss something?
Sorry, in between when I changed the serialization format.
Yeah.
Yes, it did in fact override the record in that example. Obviously, normally we wouldn't, as I said, we wouldn't advise changing the serialization format of a live node because you'll end up with half the documents with one serialization format and half the documents with another. The document store, as the transaction log, is intended to be a golden store of docs and transactions. So that's the whole Crux cluster, if you like, shares those. So yeah, it's very much a case of the whole document store needs to have the same serialization. In this case, though, it will have seen that the documents were different and felt that it needed to overwrite them.
Okay, cool.
I think there's also some settings you can configure on S3 to prevent documents from being changed, right? You'd have to explicitly delete them.
Yeah, certainly a whole lot of versioning you can do to keep previous versions and that kind of thing as well.
Cool.
But yes, a very valid point. The document stores normally, apart from the case of eviction, obviously, the document store is normally immutable.
Nice.
That the SQL support there is especially exciting, I think. Also, the whole breadth of tools that it opens up to, especially the Metabase stuff there. That was very nice to see. Good work.
Cool, thanks. I'm glad you agree. We've been thinking about SQL support, certainly since we launched last year, and it's never felt quite that appealing to hack on. It's quite a large, Java-heavy code base, but it's actually been really interesting to get into. And I don't know, John, if you wanted to say anything on your experience over the last 6 weeks, but I'll
be glad when it's finished.
I can imagine. I'm curious though, how well did the mapping go from SQL down to Datalog?
I mean, do you want to take that one?
Yeah, I can try. Yeah, so it's worth looking at the code. Maybe I can just have a look at that to show you sort of roughly what it looks like. How do I get to it? So I think it's quite natural. It's all in this closure namespace. So one of the things. So we've got quite a few Java files in here. We want to get out of the Java and into closure as quickly as possible wherever we do things. So this is really where the magic happens, where we recursively go through the sort of the SQL tree of expressions and convert them sort of clause by clause into Datalog. So here you can see we get this node kind is called equals, and we're just converting it either into an EAV triple or into a predicate, an equals predicate. It's quite. I was surprised actually. I think John or maybe Malcolm or maybe even Dominic cracked this before I really got into it. So I'm probably not the best person to comment, but I was surprised at how intuitive actually the mapping is.
Yeah, it looks very clean. That's not at all what I expected.
Yeah, and we've got things like sort by and other kinds of filtering working, and this whole file's 280 lines. It's kind of amazing. I guess it goes to prove that it doesn't really matter what your syntax is. It really is all about the semantics, and so actually, the semantics of SQL really do map to Datalog quite well, even if the syntax is all the words are in different orders. Cool. Okay. Well, if no one else has anything else to mention, thanks for your time, and we'll catch you again in a couple of weeks, hopefully. Cheers.
Cheers.